welcome to the next section, and let's just jump right in. You have learned two forms of a quadratic equation. The vertex form, y equals ax minus h squared plus k, gives you information about the transformations of the parent function y equals x squared. H and k, remember, are the vertex. It moves it to the right h and up k. You use the general form, y equals ax squared plus bx plus c, to model many projectile motion situations. In this lesson, you'll learn how to convert an equation from vertex form to general form. The general form, y equals ax squared plus bx plus c, is the sum of three terms, ax squared, bx, and c. So, a term, big and important term, is an algebraic expression that represents the only multiplication and division between variables and constants. Recall that a sum of terms with non-negative integer exponents is called a polynomial. So notice how it says non-negative and integer exponents. Alright, so that means I can have x to the fourth. That's a 4. Or y to the third. But I cannot have it be x to the negative 7th. I can't have it be a negative. And I also cannot have it be x to the negative 4.3, right? Because it can't be a negative. Also, it could not be x to the 1.8. That wouldn't work because it's not an integer. And x to the 4/3 will also not work because 4/3 is not an integer. Variables cannot appear as exponents in the polynomial. Here are some examples of polynomials. 17x, 4.7x cubed plus 3x. X squared plus 3x plus 7. 47, x to the fourth minus 6x cubed plus 0.28x plus 7. These are all okay. Even though there are decimals right here, the coefficients, the numbers in front of our variable, can be decimals, but the exponents cannot. The expression 17x only has one term, so it's called a monomial. Mono meaning one. The second expression has two terms. It's called a binomial. Two terms, bi like bicycle. The third expression is a trinomial, like tricycle, because it has three terms. If there are more than three terms, we just call it a polynomial. Alright, we got lazy after 3 and said, well, we're just going to make it a polynomial. Recall that terms whose variable parts are identical, such as 3x and 2x, are like terms. Terms such as 2x to the second and x to the fourth are not like terms because their variable components are different. Right? If I have 2x, x, and the other one is 1, 2, 3, 4, these are not the same because they don't have the same number of variables, alright? There you go. So now let's do example A. Example A says, is each algebraic expression a polynomial? If so, combine like terms and state how many terms it has. If not, give a reason why it's not a polynomial. Alright, so the first one, 3x squared plus 4x to the negative 1 plus 7. Well, this one looks okay. This one does not look okay because negative 1 is not what we want. It can't be a negative. And the 7 is okay. So really just that middle term is not so good. So we would say, no, this is not a polynomial because 4x to the negative first is the problem. Okay. So it says not a polynomial, negative exponent. Has a negative exponent. Alright, let's look at B. 2 to the x minus 7x plus 18. Well, 2 to the x is a problem. I can't have an x in the exponent. So we're going to say no. 2 to the x has a variable exponent. Alright, what about 47 over x plus 28? I will say no. That also doesn't work. The 28's okay, it's the 47 divided by x. That's the problem. And we could say 47 over x is actually the same as 47 times x to the negative 1, which is then CA. Right? If I say this happens, see what A looks like when we say we have a negative exponent. So I don't have to rewrite all of that stuff. Well, what about D? 3x plus 1 plus 2x. None of the exponents are a problem. So I'd say, yes, it is a polynomial. And it says, state how many terms. Well, can I combine anything? The 3x and the 2x are like terms. So that means it's going to be 5x plus 1. So that makes it a binomial, right? Because we have two terms. All right. E, x squared minus x to the 10th. Is that a polynomial? Yes, it is. And I can't combine anything because I have a 2 and a 10, so that means they are not the same number of x's, so we got to leave it just like it is. And I would say that is also a binomial. And then we'll do f right here. Negative 2x cubed times 3x squared. Is that a binomial? Well, let's first see if we can simplify this. All right, so the negative 2 times 3, that's a negative 6. And if I'm multiplying the bases, I should add the exponents. That's x to the 5th. So is that a polynomial? Yes, it is. And what kind? It is a monomial. Monomial, right there. Okay, so there is example A. Let's look at example B. Knowing how to square a binomial is a useful skill. It allows you to convert equations from vertex form to general form. Alright, and we're going to need to know how to do this, especially when you get to Algebra 2. So this is a good thing to know right now, because then we can also look at, if I have the vertex form, I know where the vertex is, but I might want to know some other information about the general form, especially if we're doing like a projectile motion. We could say, where does it start, what's the initial velocity, what's the initial height, that kind of stuff. Okay, so we're going to try and rewrite this expression, this equation, into general form. So we've got vertex form to general form. Alright, so what I want to do is I want to be able to rewrite this thing. So I'm going to have the y equals 2, and I want to be able to rewrite the x plus 3 squared. So I want to redo that square. Alright, so I'm going to do x plus 3 and x plus 3. Alright, so just like we did in our investigation, x times x gives us x squared. X times 3 gives us 3x. This x times 3 also gives us a 3x, and 3 times 3 is 9. Everything is positive, so now I can just add up everything in here. So I've got x squared. 3x plus 3x is going to be 6x. And then I have a 9 left over. Alright, so now I've been able to rewrite that square. So now what I'm going to do is just distribute the 2 and then subtract 5. So if I distribute the 2, 2 times x squared gives me 2x squared. 2 times 6x gives me 12x. And 2 times 9 gives me 18. And minus 5. So I just have to write one more step where I can combine these two because they're like terms. So y equals 2x squared plus 12x plus 13. And there is general form, right? ax squared plus bx plus c. ax squared plus bx plus c. So there we go. That's what it is. All right, good luck.